All right. I think we are live. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Singy, good to see you over on the YouTube side. We are going to pick up where we left off last week, and we are going to go over just a couple of updates that I was able to make offline in between streams. But the goal for tonight is to kind of continue working on our game-specific scene and see where we get with that tonight. So before I jump into that, though, I do want to just take a quick second and thank the supporters of the channel, starting with our elite partner, Javier Olazaran. That's the highest tier of subscription over on YouTube memberships and Patreon, followed by our partners, Gaboli's Inc. and Matt Oscar. That's the next tier there, followed by all the supporters you see here listed on the screen. They're a combination of the other tiers of support over on YouTube memberships, Patreon, and Twitch subscriptions. So thank you all very much for your support. It means a great deal to me and helps me cover the cost of various things associated with running this channel and project. Things like software licenses, hosting fees, things of that nature. So thank you all very much for that support. It's greatly appreciated. In addition to that, I would like to give a quick thank you to all of the viewers, whether you're joining us here live on the YouTube or the Twitch side. We do simulcast to both. Or if you're just catching the VOD after the fact, thank you very much for being here. I appreciate each and every one of you guys, because without you guys, this project and thus this channel would not exist. So thank you for being here. I appreciate you guys. All right, so tonight we are going to continue with our game-specific, or I should say application-specific scene, right? Because not all of our applications are going to require a scene per se, but this one does. So last time we were kind of in the middle of implementing the various entity types. We kind of talked about how we're going to represent entities in general, and we were just going to have entities, which entities themselves are essentially just what we call a base entity here. And all that is just a type, a name, which we'll get to here in a second, a transform, and a collection of flags, right? And that is all an entity is, right? So it's there's not much to it. And then we have specialized types of entities, which you can think of as sort of a single level of inheritance of those entities, right? So there's not a whole lot to it other than that. We're not going to allow any sort of other layers of inheritance, if you will. It is just purely going to be this single layer, right? So we have our static mesh entity and our point light entity, which we covered last time. I think we even talked a little bit about volume entities and the way that those are going to work. And so I've added hit shape entities as well. And so a hit shape is basically, you can kind of think of it as, we used to have, what did I call them in the old version? Hit spheres, right? We had hit spheres, which were specific to the sort of old way of doing things. But now we have hit shapes that allow us to have different shapes for those hit shape entities, we'll say. And so the difference between a volume entity and a hit shape entity is hit shape entities can interact with one another, or they can interact with a volume entity, possibly other stuff in the future. But the idea here is that a volume entity is basically a volume of space, or it's a section of space, right? That has certain properties associated with it. So it itself has a shape, so that might be a rectangle, or it could be a sphere, or maybe eventually some other form of geometry. But the idea is that you have a on enter command, an on leave command, and an on tick command. So whenever something enters this, the on enter command is executed. That's via our console system. Whenever it leaves, if this is configured, the leave command is executed, and then every update tick, we have an on tick command that gets executed if that's set. So all of these are optional. in theory. Ideally, you'd have at least one of them, right? If you've defined an entity, otherwise, or a volume entity, otherwise, why are you defining it? But the basic idea here is that, it provides us with a way to, define an area of space that we can interact with in a sort of non-physical way. So we have, that's the volume entity, and then the hit shape entity, again, is what we call a shape here. We'll get to collision shape in a second. And it has a collection of tags similar to the way that a volume entity has a collection of tags. So the collection of tags is an array of string IDs in both cases. So string IDs are almost the same concept as k-names, just as a refresher, only these are case sensitive, whereas k-names are not. And so the idea is that only hit shapes whose tags are defined here in the volume entity, and hit shapes that contain that tag will actually interact with the volume entity, right? So we can maybe have a tag that says player for a hit shape entity, right? And the volume entity could just interact with players and not, say, NPCs or enemies or something like that. So it's a way for us to filter what interacts with what. And so the basic example that we had sort of in the old demo was we could enter a volume that allowed us to teleport to a different zone. And so we had a command that got executed when we entered it that made some text appear on the screen and enabled us to teleport to a different scene. And then if we left that without actually performing that teleport, for example, that text went away off the screen and the ability to teleport disappeared as well. And so that is one of the uses, for example, for that. And so we used to have a hit sphere, now we have hit shapes. And shapes are basically these Illumina collision shapes, which for now looks a lot like kind of what we had defined in the sort of old way of doing things. So we have a shape type, which is a sphere or a rectangle. And then we have a union here that allows you to define a radius or extents. And the idea is that shape will then be transformed by the base entity's transform, right? And we can use that to determine collision. So that is what those two are for, and I started kind of scaffolding those off camera. All right, let me catch up with chat here. Maget's, good to see you. How are you doing? Welcome. Bit Casual, hello, how are you? How goes the engine dev? It's going pretty good. We're in the middle of sort of simplifying our code base, making things a little bit less generic, which I know sounds a little bit weird. But we're making a game-specific scene, and we're removing the sort of generic scene out of the core engine, because the scene itself, and just like the renderer, is a pretty game-specific thing in terms of how the data needs to be organized, how it needs to be represented, how it needs to be rendered, gathered, all that stuff. So we're in the middle of doing that now. Penguin Operator, hello, how's it going? Spiro, good to see you too. Fifth or something. Yeah, you probably are fifth. For those of you who don't know who Spiro is, by the way, over here on Twitch, he is a GigaChad developer here. He's a good friend of mine. I highly recommend you go follow him. He's always doing cool stuff on his channel. He does a lot of tech news, going over various things happening in the tech space. And he's also making a game himself, where his game engine is written in C, but he's using the HTML DOM and the browser as his renderer, which is completely out of the box and awesome. So if you're not following him, definitely go do it. All right. So, Psycode, how's it going? Good to see you, bud. Welcome. All right. So, Lou the Coder, second over there on YouTube. Yes, you are. Welcome. All right, so I already kind of put these in place. So if we actually take a look at our structure here, our scene, we've already got the point light entity array in here, the volume entity, and the hit shape entity. Now I put these in place. I put the functions in to add them, the functions to remove them, and we'll actually put in the processing later. We'll kind of do all that at once, I think. It's kind of going to be the way to do it. What I'm thinking for tonight is we could go two directions. And whichever direction we choose tonight, we'll go the opposite direction tomorrow night. So I could either work on finishing getting these kind of things in, where we are, kind of setting up the rest of the entity types that we need, the bespoke entity types, right? Or we could talk about what the new format for a scene is going to look like. And that's going to be a little bit of a loaded conversation because there's going to be two formats for the scene, is what I'm thinking, at least offhand. So there's going to be sort of a text version of it, or a human readable version of it, and then we're eventually going to have a binary version of it as well, to facilitate quick loading. So one way or the other, we're going to talk about both of those things, but I'm kind of leaning more towards let's just get the rest of these entity types defined, and then we'll go from there. So the only ones that we really have, I added in hit shape off camera because I had forgotten to add that there. So the only ones we really have to define are height map terrain, water plane, and audio emitter. Height map terrain, I think I'm probably just going to go ahead and stuff in here really quickly, but I'm not going to worry too much about it because there's some work that we have to do around height map terrains in general to get what we need as far as to get those working again. So that one's a little bit low priority. I'm actually going to dump that one down there to the bottom. And I guess we could go ahead and look at water planes next, right? So if we look at our old scene over here on the left, we sort of had this water plane structure, and then we have water plane attachments and metadata. So let's take a look at the metadata. Metadata had nothing in it. Cool. So the water plane itself is really what we're going to be focusing on. And that just has just some very basic data in here, right? And so I'm thinking we might even be able to use... I hesitate to use just this structure directly because I have a feeling that at some point we're going to be refactoring this, right? So I think what I'm going to do is I'm going to create a new entity type and we're just going to feed the data over. We'll copy it over as we need. But I have a feeling that we're going to need a little bit more than that, right? So let's go ahead and just define a new type here. So we'll do type def struct, and we'll do water plane entity, right? And to that, we're going to have at least some of the same things, right? So I don't completely remember why we defined a model matrix here. That's a little bit weird to me. So we're going to have to take a look at that. We have vertices, indices, and then an index buffer offset and a vertex buffer offset, which may sound familiar, right? So let's see. I think we have... I think we can use this K-geometry data structure to render this, right? Because the other thing we have is a material instance, right? The only thing we're really missing is the K-geometry data flags, right? But all this other stuff we actually have. So what we can actually do is, since we already have this K-geometry data, instead of treating this like completely different type of geometry, what we can actually do is utilize this K-geometry data, and we already have an array. In here for static mesh geometry data right here, right? So I guess our two ways of being able to do this, we could either make the static mesh geometry data generic and just say geometry data, or maybe static geometry data, right? And include the water plane in there, so that we don't have to have a new structure for it. Or we can have a separate list for water plane geometry data, which I think is kind of dumb. So I'm actually leaning towards that second idea. And so what I'm going to do is I'm actually going to take this and I'm going to move it up here. And we're just going to call this static geometry data, right? Static meaning not changing, i.e. static meshes or water planes, right? Because that kind of provides everything that we need, right? So I think it makes the most sense to just do that. That being said, we've got a couple errors in here we've got to fix. Let's just go here and fix these one by one. This one, I think it's literally just going to be removing the word mesh all over the place. So that shouldn't be a big deal. One more somewhere. Nope, that's it. Okay. Okay. So we have that. Let's see. So we have. Did we say that was the D array? Static geometry datas. It is a D array. Okay. So essentially we'll need to do this. Right, so I'm going to copy that. And I'm instead going to go. And let's see, I'm going to do. Where do I want to put this? I think we'll do this. We'll do Illumina. Oops, I don't want to be recording macro. We'll do Illumina entity, and then Illumina scene create, or add, I guess it is, add water plane. All right. The only thing I think we're going to need for this is, well, we probably ought to have some sort of properties for this too, but for now I'm just going to keep it basic. We'll do struct Illumina scene, and then kname, which I said I was going to talk about names, and I didn't talk about names yet. We do need to address that tonight. So we need a k-transform, and then I don't think we need any sort of tags or anything else. I think that should be good enough for now. All right. So I'm pretty sure. Pretty sure I need this again. Let me just copy this whole thing actually. Yeah, let's get that. Okay. So I'm going to come in here and put this down. And we'll kind of fill this out as we go. So names. Let's talk about names real quick, right? Because we briefly talked about this, or I briefly mentioned it a couple times. I haven't really talked about it. So names are k-names, right? So that's that U64 representation of a name. It's hashed, right? For quick comparisons. So every single one of our entities, which if I go here to our base entity, we have a name, right? So this is here to allow us to get the name of a particular entity, right? And since everything is going to have a base entity, we can very quickly look up what that name is. However, we're also going to have a binary search of names that are hooked to entity handles, right? And so we're going to have a name to handle as well that's going to exist. And that's going to allow us to get an entity by name. And so we haven't set that up yet. That's going to be something we need to set up very soon so that we can fill those functions in. But for right now, this will have to work. There's a couple things we need to do here. We need to get a typed entity index. We need to create a new entity and create a handle for it. So I'm just going to copy all of this logic from here. So essentially what we do, we didn't create the water planes yet, did we? Okay, let's do that first. Sorry for all the bouncing around. I think we kind of started talking about this and then didn't actually finish it. All right, so it's going to have a base entity base. And then we're actually going to have a K geometry reference. And we'll just call it ref. And because that is located there, I'm going to have to move that down, right? So all we should need, I believe, is base and ref, right? So essentially this is going to point to a particular geometry index within that static geometries array, and it's going to keep this reference for reverse lookup purposes. Will keep a copy of the entity handle. And I think between these two, that's all we're really going to need for this. Okay, so let's go back. Add water plane, here we go. So this should be water planes. Oh, I still didn't add the array. What a dingus. Okay. So water plane entity, water planes, right? And this is just literally going to be the array of water plane type entities, which means we need to come in here and initialize it. And I know we're not tearing it down. I'll handle that later. I'm not really too worried about it right now. We've got a to-do in there. I guess as I head down through this, I'm going to take a copy of this and add this so that we can get the transform for water plane. Remove entity. We're going to have to come back to that one because we don't have stuff actually loaded yet. So we're going to have to think about that one a little bit. I want to get the load done first. So let's actually handle that first. Let's see. So we go ahead and we get water planes. Let's see. Water planes. Okay. So this needs to be renamed to water plane count. And then this is going to be water plane entity. Same here. And then here we have this init base entity, which we haven't actually talked about yet. So let me just go into that. So what this does is this takes a pointer to the base entity, the entity index where that's going to be in the type typed index, the name, the type, and the transform. So if we go to that, all it does is set all those things, right? And then it sets the free bit to false. So this is just a quick way to keep us from having to repeat the same thing over and over again. Okay, so the next thing that we're going to do is we're going to search for an empty slot first for the geometry data. So this logic is pretty much the same as before. We might wind up spawning this off to a different function, right? But ultimately what we do is we go ahead and we grab a pointer to the new geometry. And we'll have to go ahead and feed in the data from the water plane, right? So the water plane itself has 4 vertices and 6 indices, right? Which is pretty straightforward stuff, I think, right? There's nothing really too crazy going on here. We have a size here, right? And we kind of use that size to generate the vertices. So I'm actually thinking, so we do that, and then we actually do a little bit of loading here of the water plane. And then we have an unload here for the water plane. So I'm almost tempted to kind of get rid of this, right? And actually just treat it like standard geometry, but I'm not going to do that for right now. I think what I'm going to do is when we create a water plane, we're going to define the size during creation, and then pull this from there instead. And then we can essentially point this to do the same thing. Let's see. Elisar, man, it has been a while since I've seen you. How have you been? This is Illumina code, yes. It's been a bit since I've seen your name in the stream. I hope you're doing well. Good to see you. Let's see. Skychip is asking, how long have you been making this? So the engine, about 4 years. It's 4.5 years, I guess, now. And part of the reason for that is because I don't work on this full time. It's like less than part-time hours every week. And I do a lot of explaining and stuff. So that makes it take longer, right? If I were working on this, if I were to talk about this in full-time hours, in terms of actually working, a standard 40, maybe 40 plus hour work week every week, and are working on it consistently and not streaming, we're probably talking a total of maybe a year of dev time so far. Maybe. I'm thinking it's closer to like probably 10, 11 months. Just to give you kind of an idea. Been well, got super busy with day job stuff for several months back to a more laid back schedule. Well, awesome. Glad to have you back. That's awesome. Let's see. Could you implement the improved swap chain into the renderer and enable it if the feature is available? Define what you mean by improved swap chain. Let's see. From Lake, good to see you as well. I'm doing well. Thank you for asking. How are the custom scenes going? Custom scenes are going well. We've really realistically got a couple more entity types that we're putting in. And then we'll have to talk about how we're going to render all those things and get them to interact with each other. A lot of which is done by the renderer in terms of like water planes and stuff like that. But, there's a few things that we're going to have to manage, like our volumes and our hit shapes and things like that. We'll have to figure out those. There's some other stuff like we don't have skyboxes in yet, which is only going to be one skybox. We don't have the directional light in, which is only going to be one of those. And then we have to figure out the format, like the new file format, which is probably not going to be that far removed from the old version, but it's going to be different enough where it's going to be worth discussing and worth thinking about anything we might want to redesign along the way. Like the image being finished, presenting fence thingy, just to get the resizing as smooth as possible. Oh, I don't know. So I know there's a bug with that's been reported a couple times on Discord. So I'm going to fix the bug, and if we can put that in place along with it, then cool. If not, I'm not that worried about it, right? Because one thing I don't think I need to handle gracefully is like having the whole game recalculate smoothly while you're resizing the window, right? Like that's just not an important thing that I need to focus on. I'd much rather have it just say, you know what, wait till you're done resizing and then just recalculate all at once, instead of, having it smoothly do it like as you're actively resizing the window. I'm probably not going to worry about that. If it doesn't work after the fix I put in, then I'm probably not going to do it, just because it's not worth the effort. Swap chain maintenance 2 is probably what Magats is referring to, which adds optional fence to VKQ present. Oh, okay. I have to investigate that because I don't know what the hardware support is like on that. And honestly, if it's not very much, I probably won't do it either, simply because I don't want to have multiple code paths for a whole bunch of stuff. If I still have to support the old way of doing it anyways, then what's the point? Let's see. In theory, it's used for making sure all previous swap chain images are done being used before queuing a deletion. So, probably the way that I would do that is just wait a couple of frames before trying to delete it, right? Or wait a couple frames before destroying the old swap chain, and you accomplish the same thing. So if I were to implement that manually, probably what I would do would be just once the resize is done, I would just throw the old swap chain into a queue. And if I wanted it to sort of dynamically resize and keep resizing, I could just keep creating swap chains, but instead of immediately deleting or destroying the old one, I would be putting them into a queue, which our update loop would check every single time. And that queue would only essentially pop one off after X number of frames. Say 3, or it would probably be however many frames in flight you have plus 1, just to be safe. I don't recall if it's MP next or a different VKQ present, because I don't use it myself. It's one of the two. Yeah, it sounds about right. Sounds complex for minimal benefit. Yeah, and that's my point, right? Like, I mean, it's not really that complex, right? Setting up a queue is pretty simple. And just like deferring the texture deletion for a couple of frames is not that big of a deal. Or not the texture, the swap chain deletion is not that big of a deal. That's a relatively easy thing to set up. It's just, if I have to do that anyways for hardware that doesn't support the new way of doing it, then I'm not going to do the new way of doing it. I'd rather just do it the old way. You're just waiting for the fence before recreating the swap chain? No, I wait a couple of frames, right? So you create the new one immediately, but you wait to destroy the old one, is what it is. Yeah. I do the same thing with textures, actually. I've actually got a queue that I put textures in to be deleted after a couple frames, just to ensure it's not like in use by a queued up frame, or a frame that was being a frame that had already been, or I should say a frame that was already being processed and the commands were already being built for a frame that uses that texture, just to avoid any issues with that. I wait before unloading a texture a couple of frames before I actually unload it. So it's the same concept. Okay. What's the old swap chain field for in the swap chain create info then? That's to delete the old one. But I've never used it for this reason. Sounds like you could recreate a huge amount of textures. Not really, right? Because if you think about it, so I only check the swap chain to see if it's out of date once per frame, right? So if it's out of date, then I say, okay, I need to create a new one. So I go ahead and I create a new one, and then I boot out of the renderer. And right now, I think what it's actually doing is I create a new one, tear down the old one, and boot out of the renderer. And then I try again the next frame to say, hey, is the thing ready yet? What I would do in this case is I would see, hey, I'm resizing this frame. Okay, we need to create a new swap chain if the size has changed. And then take the old swap chain handle, put it into a queue. And in that queue would also be a frame counter for each individual swap chain to say how many frames have passed since this thing entered the queue. Then the next frame, I would try again and say, hey, well, maybe the new swap chain isn't ready yet. It's still being created, so boot out, but also increment the counter for the old one, right? And then the next time I come in, okay, cool, the new swap chain is created. Go ahead and use it, render the frame, whatever, increment that counter again for the old swap chain, and then say, all right, on the next one, I come through, okay, well, now the actual count or the counter for that particular old swap chain on that next frame would be 3, which let's say that's my threshold. So now I can go ahead and unload it, right? Just can't use it, but wait, you just can't use it, but it doesn't delete the old one. You still need to delete it manually. Yeah, see, I've never used it because it didn't make any sense to me. Not every driver makes good use of it, but those that do can accelerate the swap chain creation quite significantly. But again, like, is swap chain creation something you really have to do all that fast in the grand scheme of things? Because the only time you really do it is like on a window resize, right? You're changing resolution. Generally speaking, that's the only time you're going to be doing it. So like, okay, if you've resized your window and it takes a millisecond to recreate your swap chain, or I don't know, even 16 milliseconds, right? Okay, so you lose a frame, right? Like you're resizing the window, that's kind of an expected thing. Yeah, so I don't know. I wouldn't really worry about it, personally. Thank you for the sub over on the YouTube side. Appreciate that. I am still working on it. Yep. Nice theme. Appreciate that. Let's see. Very exciting progress once again. You keep delivering. I appreciate that. Oh, who's a dingus? Thank you for the follow. Appreciate that. All right. Anyway, I should probably get back to this because I've gone off topic. All right. So, whenever we add the water plane, we essentially need to get a free static geometry data. So we go ahead and do that. We set up vertex count, right? So vertex count we always know is going to be 4. And index count we always know is going to be 6, right? Now, vertex offset is going to come from the water plane itself. And this is kind of where I was like, well, do we just do this kind of in line in here and get rid of the whole water plane file? This is only 100 lines of code, and most of what it does is kind of not much, right? Thank you for the follow. Appreciate that. I'm debating. Right? Because like I kind of feel like we don't need this file. We could just extract this and just have the scene do it. Granted, if the scene doesn't exist for a game, that would have to be done in user code, but this is kind of user code anyway.
You dingus.
Thank you for the follow. Appreciate that. Is my actual, is the display showing when that happens? I haven't actually been paying attention. Should probably test that real fast. One moment. Let's see, where is it? Thank you for the follow. Appreciate that. I guess I only changed on the Twitch side too. I did not change it on the... I apparently did not change it on the... Apparently did not change it on the YouTube side. All right. Well, it is what it is. I'll try and keep a closer eye on it, see if it pops up. All right. So at this point, we should probably do... Let's see. This is all synchronous, right? So water plane load. I really feel like this should probably just be... Because like half of this stuff is hard-coded anyway, right? So one thing we talked about, we want a size. So we should probably put that in here. So we have name transform. We can have F32 size in here. And so we can do all of this stuff. Right? Probably here. Setup geometry. Right, and then instead of plane vertices, I guess we can just do water plane vertex. In this case, I'll just do vertices, and we'll do an array of 6. Oops, an array of 4. And then we'll just do that. And then U32 indices. And that's going to be an array of 6 of those. And we'll do that, right? So we'll set up the geometry. And then we'll do this. So actually I'm going to do all this here. Because I don't really like the way that this works as it stands. So let's see, plane material. So this is going to have to go down here. Oops. It's going to have to go down here. Here, right? So we'll just do a K material instance. We'll get the material there, and then we'll do, I guess I should probably actually call that mat inst. So we can get that. Now we have the instance ID. And then here, all we have to do is, first of all, include the renderer. So essentially what we do here is we grab the vertex and index buffer, We allocate some space in the buffer, and then we can output the vertex buffer offset, which I think is a U64. Yes. So we can do here, I'll just do U64, vertex offsets, and U64 index offsets equals 0, right? And then I can just do that and that. Okay, so we allocate some space in those buffers, and then we go ahead and upload that data. And here we just use local arrays, right, which are just on the stack. That's fine. We don't need to store that any further. And then they're loaded, right? So that's nice and easy. We have the vertex and index offsets that we need here. So now all we have to do is come here and do this. Ooh, that was a bug, actually. This has been wrong the whole time. Or no, this is wrong somewhere else, actually. Where did I copy this from? That should be index buffer offset. Glad I caught that. Okay. Here we go. All right. So allocate space, upload the data, we should probably say. And then here, like once that upload is complete, we actually have all the information we need to fill this guy out. So we fill that out, we create a new geometry, right, in that array. And then we just need to fill out the actual, geometry reference, right, which is going to be in this new entity. Let's fix this first. So this is going to be false. We're never going to have inverted winding on a water plane. I just don't see why we'd ever have to do that. So here we have new entity, and we want reference. So the entity is going to be the handle, which have we generated the handle yet? I don't think we have. Yes, we have. Okay, so that's going to be handle. And then new entity ref geometry index is going to be array index, which I'm going to rename that to geometry array index. Okay. So we do have a note about making the water material configurable. We can come back and add that later on. I think that's fine. There are a couple things here. So we're returning an Illumina entity, right? If for any reason this kind of stuff fails, we don't want to return false. We actually want to return Illumina entity invalid. False is just 0, and that's technically a valid handle, right? All right, and then finally down here, return handle. So that is loading a water plane, right? So again, just to recap, we take our size in here, we go ahead and we create our verts based off of that size. We create our indices, which is always going to be the same anyway. We go ahead and we allocate from our index and vertex buffers. We upload data to those buffers. We search the static geometry array index, or the static geometry array for a free index, or push a new one if not. We grab a pointer to that. We go ahead and grab the material that we need. We set up the new geometry as needed, right? So we set up the vertex and index count and offsets. We set the material instance ID. We set the flags, specifically winding inverted, we set to false because we're not going to support negative scale on water planes. I don't think we need to. And then we go ahead and we set the, in the entity reference itself, we set the handle and the geometry array index. Now, we're going to have to undo some of this stuff when we go to unload this thing. So that's kind of the second part of this. And that's kind of why I wanted to tackle this one first. So we have water plane. We're going to come up here and we're just going to go right here. We can essentially take, I guess we can do our static mesh, right? We can use that as an example. So I'm going to put this here, and we're just going to change a few things. So instead of static meshes, obviously we have water planes, right? Here again, water planes, water plane entity. Okay. Now we don't do this unmap entity geometries. We don't need to do that. What we do need to do is we need to go through and unset the geometry reference, right? Let's do k geometry data. Is going to be equal to the address of scene static geometry data's sub. And then this is going to be typed entity. Let's see. Thank you for the sub over on the YouTube side. Appreciate that. Let's see. Let me catch up on comments really quickly, actually. Hello, Abel. Gabe is asking, sorry to ask a noob question, but what graphics library should I use to make a game purely in C? STL3, Raylib, OpenGL. Are there any example repositories of good C code? So Raylib is a pretty solid library if you want to use a library to do that. And it kind of abstracts OpenGL from you, right? So like if you're not familiar with graphics programming and you're only looking to write game code, that's going to be the way to go. STL is pretty good as well. STL obviously can work alongside OpenGL. OpenGL, if you're wanting to learn graphics programming, like the low-level graphics programming, OpenGL is the place to start. And then once you get decent with that, you'll want to jump to Vulkan, but it depends on what your goals are, rather. So it's a bit of a loaded question, but it depends on what your knowledge level are, or what your knowledge level is and what your goals are. I can't speak tonight, apparently. All right. So we grab the geometry data, and we'll go ahead and set the flag on that data. So we'll do flag set, and we'll do data flags, and the k geometry data flag free bits we're going to set to true, right? And that essentially marks that one, right? Let's see. What am I missing here? Why is this bleating? Typed entity. Oh, it should be typed index, not typed entity. Okay. So we free the, or I guess we should technically say mark the geometry data in the array as free. Should be mark the entry in the geometry. Wait, no, mark the geometry data entry in the array as free. There we go. Okay, so we've done that. Then we need to, well, before we can actually do that, we do need that data to actually release stuff, right? So we're going to do that first. And for that, we actually have the unload here. So we can actually just grab this because this actually contains everything that we need. So typed entity will give us all the data that we are going to require for these operations. So we'll go ahead and do it below that. So we just free from the render buffer, right? That's going to be, let me see. Nope, we do need the geometry data up here. We do need this here. But we need this to be down here. Okay. So this is going to be data.vertex offset, and then data index offset. Okay. And if there's an error when we're actually removing an entity, this is return type void because there's not really much we can do about it. So I'm not going to return here. I'm just going to bleat about it and move on. And then we need to release the material, right? So this is also going to be data material. Wait a minute. This wants the full material instance. Okay. I guess when we get this then, let me think about this for a second. So when we get the material, which is here, we have the material instance, and I guess we're only saving off the instance ID. So what we should probably do is on the entity itself, we should probably store the K material as well. So we'll do K material, base material. All right. That way we don't have to relook it up later. So new int base material equals mat inst base material. And then we can come back up here and we can actually make a new instance out of this, right? So we can do K material instance inst equals, right? And then we can do base material equals data, not data, typed entity, base material, and instance ID equals data material instance ID. And we pass that into that function, right? Okay, so we release the material. That should be all we really need to do as far as unloading goes, right? Because we don't store any of the actual geometry data in here. So that's unloading, right? Chances are we're going to have to remove some of this stuff too, because we're going to have, this is sort of just removing an individual entity. We're probably going to want to wait and like mass unload stuff, but we'll get there in a minute. Let's see. What IDE is this? This is NeoVim. Yeah, so in fact, there is a link to my website where I wrote up an article on how I have my NeoVim set up, and it has a link to a dot file that you can use. Out of pure curiosity, how far do you intend to push the development of the engine? All the way to completion of a released game. At least one released game. So the goal is we are going to release, we're going to take a game all the way to release on this engine, which means building all the tools and stuff we need along the way as we need them. And we are going to release the game on Steam. Like, it's going to go up for sale. Like, we're going to actually fully release it, right? Steam is the first platform that I'm going to do. I might expand to other platforms eventually. And right now, as far as my initial goals for this is I'm going to support Windows and Linux out of the box. And maybe Mac OS. But I'd really like to get the Metal renderer written before we actually do the Mac OS port. But we'll see where we wind up with that. I hope that makes sense. Okay. Am I using a multimedia library? What do you mean by a multimedia library? Like for my audio? I mean, no, unless you consider OpenAL that, right? Because we kind of have our own audio set up through OpenAL. So we wrote our own audio system from scratch on top of OpenAL. I didn't feel like writing one for each like sound system available on Windows, Mac, and Linux, but yeah. Android and iOS are planned for the future. They are not going to be... So this particular game is not going to target those platforms. Future games might, though. So what's doing your window creation and shape drawing? Myself, and I. I went in and I implemented all of the Win32, X11, and Cocoa stuff from scratch. So all of those, all that logic is located in the platform layers for each platform. So if we take a look at the engine itself, and excuse me, and then platform. Let me expand this a little bit. So, whoops. So over here we have platform Linux, Mac OS, and Win32. Nix is not like the Nix version of Linux, right? It's kind of shared stuff between Linux and Mac OS. Because there's a lot of overlap and similarity between these two. So Win32 is just using, your standard Win32 library. Linux is using X11 for now, with Wayland support in the future. And then, Mac OS is using all of the Mac stuff like Cocoa Foundation, all that stuff. So yeah. That took a while to write, but we said we were going to do as much as we could from scratch, so this was part of it. Metal is obnoxious. I just stuck with GLES for everything. So I've heard mixed opinions on Metal. Some people swear by it and say it's an excellent API. Others hate it, right? So I've never worked with it, so when I go to actually write the Metal backend, I'm going to be learning that as I'm writing it, which should be interesting. And that's actually the next backend that I plan on supporting, even over Direct3D, because Windows supports Vulkan pretty well. But yeah, should be interesting for sure. I've heard it's a pretty decent API to work with, but until I actually work with it, who knows? All right. Where were we? So that's water plane load and unload. So essentially we don't even really need this anymore, but there's other parts in the older legacy code that rely on this still, so I can't delete it yet. Okay, height map terrain I'm not going to worry about for right now. Audio emitters though. audio emitters we can do. So let's take a look at how our audio emitters look. Why do I have that? Wait a minute. Oh, because the scene 4 declares it in the H file because we had, oh, okay. All right. Ignore me. All right. So we need a new entity type for audio. And if we look at what the existing one has, so it has a K audio emitter. This comes from the sound system itself. Then we've got some debug data. I'm not going to worry about copying that over because we're going to handle that completely different. We have a generation, a resource name, a package name, and whether or not it's streaming. So streaming is typically used for, audio streaming is typically used for longer audio bytes like songs, where it continuously streams from the file instead of loading the whole thing at once. And that's just kind of configuration of the actual entity, right, when we create it. So,
you dingus.
Thank you for the follow. Appreciate that. I don't think my alerts are actually showing on the screen, which is really annoying. I'm going to test trigger one real fast and see. Because it should be, like, I'm hearing it through the headphones, but I'm not so sure that it's actually... Let's see. I know there's a way to test this. Here we go. So I'm just going to test a follow.
You dingus.
Yeah, it's not showing up. What the heck? It's being a dingus. I thought so. Yeah, see? Another follow. Didn't show. What the heck? Yeah. Very, very weird. I'm going to have to figure that out off stream, I guess. Not sure why that's not showing up. Streamlabs is always breaking. It's kind of annoying. All right. Wayland has a strict no tearing policy. Yeah, that should be fun to deal with. There's an option to allow tearing in full screen, but I don't know if it works. Yeah, and who knows? Depending on how the desktop environment is implemented, it may or may not work inconsistently. Gotta love that. All right, so we're gonna have a structure. We're gonna call this a audio emitter entity. Audio emitter entity. So obviously we got to have the base entity, base. That's a must. And then we can actually have this over here. And then let's see, we don't need debug data. Resource name and package name and is streaming, I guess, are what we need. So I'm going to do kname, and I'm going to call this asset name, right? Because resources kind of aren't a thing anymore. Kname, package name, right? These are for serialization purposes, right? So I'll just leave those there. We'll include the audio system, and then generation. I don't know if I really need to worry about that either. And then we have this B8 is streaming. And as I've mentioned a few times, like, I don't really like Booleans like this, right? Because Generally speaking, you wind up having more than one of them. It's just kind of wasteful at some point, right? So I like to, I've actually started like converting this stuff to use flags instead. And I think I'm going to do the same thing here. So we're going to do a type def, and we're going to do enum, and we'll say audio emitter entity flag bits. Audio emitter entity flag bits. Right, and we'll do audio emitter entity flag none, right? That's always going to be an option. And then here we can do, we'll do streaming, right? And we'll do, this will just be 1 offset by 0, which is 1, right? So this one will be used for longer audio assets such as songs that should stream from the source instead of loading the entire thing. I spelled entire wrong. And that's mostly a back-end detail, but we need to tell it one way or the other that that's the case. And then I just like to also type def. Oops, how did I? I also like to type def. I'll say a U32, and I'll do an audio emitter entity flags, right? And then down here I could just say audio emitter entity flags. Right, and that will allow us to add options to this later, which I think we're going to actually want to do. I've already got a couple things in mind that we're going to add to that. So it just kind of sets that up nicely for us. Now this generation thing, I actually don't remember what that's actually used for. So we'll have to, we'll actually have to take a look at that. So down here, we'll have to create obviously a new D array. So this is going to be audio emitter entities, audio emitters, audio emitter type entities, right? So we have that. Obviously, we'll have to do this here, instantiate the array. What did I do? Audio, whoops, crap. Audio emitter entity. There we go. So we have that. And then down here, we just need to hook in the transform bit of logic, which is just that. Audio remove entity, we're going to come back to that, right? We're going to do the load first, and then we'll handle the unload. So what we'll need here is just another sort of, in fact, I'm actually going to copy from volume because I kind of maybe hit shape. All right, because this one's kind of simple and gives us some of the things that we're going to need. So this is going to be add audio emitter. Okay. Now we don't have tag counts. We don't have tags. So we need obviously a pointer to the scene, the name, the transform. So the other things that we're going to need, let's see. I think we do have a bunch of configuration properties here, right? So we actually have this inner radius, outer radius, volume fall off, looping, streaming, resource and package name. Obviously we need to change that. So these are all properties that we should probably take in for the creation of this, right? So I suppose we should do, I guess, F32 inner radius, F32 outer radius, F32 volume. Let's see, F32 fall off. Okay, so we have looping and streaming, right? But I think as properties of this, like, or as parameters, I think it's fine to use booleans. I think that's makes it a little bit easier on the user. So I'm going to say is looping, and B8 is streaming. Right, looping is already one that we have to add to flags, by the way. And then we'll have kname, asset name, and kname, package name. All right, and that should give us everything that we need to actually build one of these things. So here we're just actually doing some debug data stuff. We don't actually need to do this. We're going to handle that differently. So I think the only actual section of this that we need is just this, right? So this is going to be the main portion of it, right? And then instead of obviously having all of this attachment config stuff, which we don't have here, we can just use these properties directly. We can say asset name and package name, right? And then we have emitter. So we don't actually have this yet, so we've actually got to create that. And in order to create that, we need to do something like this. So let's go ahead and grab that and come down here. And instead of water planes, it's going to be audio emitters. Right, audio emitters. One more here and one more here. So this is going to be audio emitter entity there. And then audio emitter count. And I just realized that this thing is misspelled up here for water planes. Let's fix that. Okay. All right, so we go through, find a free slot and use it if there is one. If there's not, we add a new entry and use that. This is going to be audio emitter entity. So we select an entity, we create a handle, which we need to change the type here to audio emitter. Okay. So that's good. Now, new emitter, right? That doesn't really exist. That's going to be new ent emitter, right? And there we go. So that's all there is to creating it, right? The sort of audio backend takes care of the rest at this point. So I believe the only thing that we actually need to do from here is just to return the handle. And now that's done, right? So I can actually grab this, head over to, oh, I didn't do it for either one of these functions. Okay, let me grab this one then, and this one. And we'll head over to the header file. Right, and I'm going to actually go to here, and I'm going to do change that and change this. There we go. I suppose we could make this kind of consistent formatting wise. Okay, so now we have our add audio emitter. So that's pretty straightforward stuff, I think. Now we just need to handle the remove, right, which is here. So the remove is going to be key audio emitter. Oh, we don't have to load. I forgot we had to do that. That's a step I almost missed. Okay. We need to do that all in one shot. So it needs to be... Let's see. What did we do? It looks like we have some sort of fallback here. We also have a world position set. Okay, so we need to actually get that. Remember when Xorg was new? Not even sure I've used Wayland. Dang. Let's see. Light Up 79, first time chatter, welcome. Do you make games in C for your day job? I wish, but no. I wish. I mean, I suppose if I get a big enough following on here, I eventually could, but I'm a long way off from that. Let's see. It's amazing to watch this while programming my own Vulkan engine. Awesome. Wonder who programmed it? Who programmed what, Abel? What do you mean? Okay, so I need to do this. So let's see. If this fails to load debug data if it was set up, then load the emitter. Why are we doing that?
You dingus.
Yeah, Dingus is right. Thank you for the follows, by the way. I'm not actually sure what the second... I'm wondering if this is like a copy pasta thing. Because if this load succeeds, then we're just doing this twice. Which is kind of stupid. I'm just going to delete that. That's... does not need to be there. All right. So we need to take this over here. And move this, bat this back out of the way. So this is going to be engine systems gets audio system. And then emitter is going to be new ent emitter. Okay, so we need to do that. And also, once that's loaded, we also need to get the position for the audio emitter based on the transform that we passed in. So what I think I can actually do, I think based on its owning nodes transform. Okay, so the old way that I had to do this was kind of... I guess I could do it this way. I guess that makes sense. Sure. Why not? So k-transform handle. This is just going to be transform in both those cases. So I should be able to get that. That should be fine. And then engine systems gets. Oops. Keep hitting the wrong dingus key there. Audio system. Whoa. Large raid. Jonathan Blow with a raid of 341. What's happening? Welcome, raiders. Thank you so much for the raid. I really appreciate it. How are you guys doing tonight? I hope everybody's doing well. So I guess I'll give the quick spiel as to what we're doing. So this whole project that we're working on right now is we're working on something called the Kohi game engine, which is a game engine written completely from scratch in C using Vulkan as its initial rendering backend. I have it planned to also support Metal and Direct 3D as well. And so we're doing this kind of as a educational exercise on a way to build a game engine. It's not the only way to build a game engine. It's not even always the right way to build a game engine. We kind of do a lot of experimentation on here and trial and error. And we walk through thought processes and do deep dives on what works and what doesn't and why. So it's kind of designed to be an educational experience from, showing you how I'm tackling building a game engine from file new all the way to releasing a game on Steam. And so the engine itself is open source. It's Apache 2.0 licensed. So once it gets to the point of being usable, that just basically means it's free for use, whether it be commercial or independent, does not matter. All that I ask is that you just say you used it. That's literally it. So the idea behind this is there's not going to be, since it's an educational resource, and I believe that kind of stuff should be free, I'm not ever going to paywall anything having to do with the engine itself. It's always going to be open source and free, freely available. So we do simulcast to YouTube and Twitch. The engine itself's been under construction now for about 4.5 years. But that's with the caveat that I work on this less than part-time hours every week. So, it's maybe 10 hours, maybe 10, 15 hours a week. And so we've got just a couple of test scenes here. I can't actually run it at the moment because it's broken. But we've got a basic PBR pipeline with some cascading shadow maps, a basic editor that we've written. UTF-8 text rendering is in place. A whole bunch of stuff. So essentially I've got a massive to-do list here that I am working my way through with different releases planned, full of different features and stuff like that. As far as the game that we're going to make with this, we've already kind of started diving into that a little bit. So we're going to be making a 3D isometric action RPG. Yeah, we've only done some loose requirements gathering and design. We're still actually drawing up a lot of the design on that, but that's the kind of game that we're making. And so that game is called Shadows of Illumina. I don't really have anything to show on that except maybe a world map, but that's not really... there's not really too much in that yet. We're just kind of getting started on that. But yeah, actually making a game, not just an engine. Yep, exactly. So that's the whole thing is like, if we're just going to, there's no point in just making an engine just to make an engine. We're actually making this with the goal of releasing a game on Steam. Like, we're going to take it from file new, no lines of code written, nothing written, all the way to releasing a game on Steam. Arch, by the way. Yes, exactly. Yeah, I'm on Arch at the moment. I jokingly named my... I set my host name to Arch, by the way, because people kept asking me about it. So, but yeah, thank you guys so much for joining in. And yeah, if I really appreciate the raid, Jonathan. Thank you so much. I don't know what to say. Thank you. That's huge. I really appreciate it. All right. So where we were at is I'm actually in the process of cleaning up and deleting code and simplifying things. So one of the things that we had tried was we tried making like this fancy render graph and fancy sort of generic scene that could take all of these different types of nodes and attachments and all this other kind of stuff, ultimately to illustrate why that's a bad idea. Ultimately we have decided that we're going to go a bit more of a bespoke route, right? Because when you think about how a renderer needs to work and how a scene needs to work, that varies greatly depending on the kind of game you're going to be making. So the kind of game that you're going to be making, The application is what understands what the data is, how it needs to be represented, how it needs to be transformed, how it needs to be represented in memory, ordered, the order it needs to be rendered, how those things interact with one another, and just having lots of these generic systems just kind of get in the way, right? And so we kind of went that route, right, to show why a lot of people do it, but why we're not going to be doing that going forward. And so we're switching away from that stuff to a bespoke application renderer and a bespoke scene specific to the game that represents things in the game as the game actually needs them to be represented, so that we don't have tons of transformations to do all the time. So an example of this is, take for instance, we have a bunch of static objects in the scene, all with different materials, right? Generally speaking, when you want to render a bunch of those things, a lot of tutorials and other things out there will kind of say, well, you just set up a class for that thing, and you kind of iterate through a scene graph, and you draw each individual thing. But what that leads to is you actually having to switch a whole bunch of stuff in your shaders all the time to keep switching material data, because all of your static meshes have got all these materials all over the place. When really what you need is that data represented in such a way where it's organized, say, by material, where you can say, okay, I need to set the generic material properties that's common between all of these material instances first, so I don't have to keep setting those things. And then as I draw each individual instance of that material or instance of that geometry, then I only set what I need, right? And it keeps the amount of context switching in the shaders down. And ultimately, that's what you want to, that's how you want your renderer to work. And so if that's what your renderer needs, why not also represent it that way in your scene, or at least a view of your scene, have it represented that way. And so that's kind of what we're in the middle of now, is really thinking about how this data needs to be represented by the time it gets to the renderer, to make that process as fast as possible with as little transformation as possible. But then also thinking about it in such a way where any interactions between all of these various entity types are represented in such a way where those interactions are quite simple. And so what we're doing is we have this single, and I use the term inheritance loosely, right? Because this is C, first off, we don't have classes, right? So we have this sort of base entity that we're building up that's got sort of an entity type with a bunch of known types in it, right? Of the different types of entities. And then we have, bespoke types on top of that, right? So we have like a static mesh entity, a pointlet entity, a volume entity, and this is the only layer of inheritance that we have. And so in each one of these, we have obviously a base entity, and so that allows us to cast any of these entity types down to a base entity type, or a base entity structure rather, but also by including its type as the first entry in base entity, I can also take any entity and cast it to entity type and automatically get its type very quickly. And so it's just kind of thinking about things like that, that we're trying to work our way through to make this a lot easier to use and more efficient. So I hope that makes sense. Knew about this game engine, but I didn't know there was a Twitch channel. Yeah, so the Twitch channel is relatively new. Well, I say relatively new. I guess I've been doing it now for a couple of years. Yeah, the YouTube channel's been around a lot longer. So, okay. I don't even know where I was. I think we were talking about audio emitters. So obviously I've got some things in here to figure out as far as transforms go. So the way we represent transforms is our transform. Thank you for the follows, by the way. Our transform hierarchy is actually represented separately from all of our entities in the scene. So our transform hierarchy is basically a view of the scene. You can think of it like that. And it doesn't even actually require that every node along the way has a transform. You can actually parent entities to other entities that don't have a transform, and it could just skip that entity up the tree and look further up for a transform. So that's kind of an exception case where you want to do that. I don't know if I'm going to support that long term, but right now it actually is capable of doing that. And so my initial thought process is that you might have entities in a scene that sort of act as a folder or don't really need transforms. Like think of a skybox entity doesn't really need a transform, right? For example.
Dingus.
Thank you for the follow. And so I didn't want to enforce that all entities have to have a transform. But anyways, we sort of have this K transform system that we've set up. And that actually not only handles all of our transforms for us and manages the data for those transforms, but also allows us to use transforms across systems and handles the hierarchy of those transforms and allows us to parent them to one another and things like that, without us having to pollute our sort of scene with that, right? So we don't wind up with this tree full of pointers to entities and pointers to lists of entities and stuff like that. We literally get our transform from a view, and we can reprocess that view and use that to reverse lookup into our entities if we need that kind of data. So yeah, I hope that all makes sense. I was trying to kind of reduce that down as much as I possibly could. All right. So, where we were at was we were actually wrapping up our last entity type that we're going to implement for now. We have all the other ones done. And then we're going to start talking about like the format of the actual file to represent scenes, because we had sort of an old format that kind of worked, but it was a little bit more verbose and complex than we really need. So we're going to simplify that as well. And I should mention that in the simplification pass that we've been doing, I've been averaging almost a 1-to-3 ratio in code added versus code deleted. So we're actually simplifying things a lot and making things lightweight. So this should be new entity emitter. All right, so what this does is we pass in a transform handle here. And then we go ahead and we get the world transform on that. If it's a valid transform, if it's not, we just use identity. And then we extract the world position from that and go ahead and set that in the audio engine for this particular emitter. I think I do need to probably save off some of these properties because, well, I guess I really don't have to. I could cache these properties, but I don't think I need to. I suppose if we have to change these things, I could actually just edit the emitter and tell the audio system we have new properties. So I'm actually not going to worry about caching any of these properties for now. So when we create a new emitter, we have an inner and an outer radius, a volume, a fall off, whether or not it's looping, whether or not it's streaming, meaning that it doesn't load the entire audio byte at once, but streams from the asset and then the asset name and package name. I think this is good enough. We return the handle to our entity. I think that is good enough. Incidentally, an entity is nothing more than a U32 as far as the rest of the system is concerned. So this is essentially the external handle to an entity. So we're not passing big structs around. Any sort of external reference to an entity is a U32. And that is split in half. So the first few bytes of that is basically an entity type. So it's basically direct castable to this. We could just, unpack that. And then the second half of it is a U16 type index. And so we pack both of those values into a handle. And that's how we get that. And so for functions that can work against any type of entity, we can extract both the type and the index by only passing a single number, which works pretty nice. That has actually worked out nicer than I thought it would. Okay, so we have that all created. I think we probably ought to start talking about the file format, right? Because that's really the next thing is going to be parsing the scene format. And And I think we probably need to discuss what that scene format should look like in order to give us all these different entity types, right? So I'm actually just going to close this out real quick. And let's do zone. I guess I can do this one. Thank you guys for the follows, by the way. I really appreciate that. All right, so this is what the last sort of format for the zones look like. And it's okay, right? But I think there's lots of room for improvement here. Incidentally, this is a format called KSON. So it stands for Kohi Storage Object Notation, right? It's kind of a rip on JSON, but it's not JSON, right? It's kind of a simpler language than that. And we did that sort of as an exercise about how you might write a parser, for example. And so we have that, and we use that to serialize and deserialize. So we used to have this concept of nodes, and those nodes could have attachments, right? So this is a little bit like, sort of like an entity component type deal. And I didn't really like the way this was coming out for the reasons I talked about earlier. Some of these things don't really need to be attachments. Some of these things don't really need to be anywhere near as complicated as they are.
You dingus.
Thank you guys for the follow. Appreciate that. So instead, what we're going to deal with is entities, if I can spell it right. And entities are going to have basically no attachments. They're only going to have properties for themselves and children, essentially. So, for example, if we wanted to emulate this setup here, instead of having attachments, we would have children. And then each entity can define minimally like a name and a type, right? So if we don't define a type, then that type is considered none, right? So a type of none entity would basically be used as a container to hold other entities if you wanted to have that. A case in point is this environment here, right? So we've got this sort of empty environment node, or entity now that we call it. And inside of that, we have a skybox and a directional light. Now, this was when we could support, or when we were thinking we would need support for multiple skyboxes and multiple directional lights. We're not going to need that. So I'm actually going to wind up deleting this, and we're going to make this, we're going to make these global properties of the scene. So I'm actually going to take, let's see, I'm going to take these. I'm going to put them here. And let's do, let's say skybox asset name and skybox asset package name, right? Because that's really all that's necessary for a skybox. So we don't need this, right? And the directional light is kind of the same thing. So the directional light just holds, obviously, properties for the light itself, but also shadow mapping data, which I guess kind of makes sense to store it with the directional light, since the shadow map is directly based off of the directional light. So I guess we'll call this that's really long. Directional light color. I hate abbreviating stuff though, so I'm going to go with this for now. And I can always shorten it later, or maybe add aliases or something, because we actually can do that here. So there's that. So that means we can get rid of this entity entirely, right? Now spawn points, you know what? Spawn points, that's something we haven't actually thought about. So spawn points were just kind of a marker that we just kind of hacked in. That was basically a node type. It was kind of like a typeless node that we were using before, and we were just using the transform as the spawn point. But I think we should actually have a spawn point entity type. So I'm actually going to, let's keep that in there, but I'm going to put a type in here. And we'll do spawn point. So I actually want to make that a type of entity. So I'll need to add that to the list, etc. And the reason that I'm going to separate that from just your standard entity type is because a spawn point not only has a transform, but it could also, you could maybe, we could maybe randomize some of this stuff. So we could put like a position randomizer in there where we could randomize on each axis just a little bit to have a little bit of variance. Or maybe the rotation, just so that we have a little bit of variance every time we use it, just to kind of break things up a little bit. So spawn point obviously is where you spawn something in the world. And so maybe we want to add some additional properties to this later, but for right now, I think this will suffice. So just as a refresher here, this is position, rotation, which is a quaternion here, and then scale is the last, right? So we have that. And then, so the player, that's going to be another specific type that we need, right? And we have like this player mesh and attachments and all this other stuff. So this is actually something that we probably are going to need to think about a little bit more as well. We are going to need a player type of entity. But that, that player type of entity might be composed of a few different things. So we're going to have to think about how we want to do that. Because it's going to need some sort of visual representation, right? So maybe I'll leave this as is for now, and we'll come back to it. So essentially what this is this is the outer mesh. That's what we use for transform, right? We transform this. And then this inner one here, we actually use for rotation. And then we have the visual representation here and a hit sphere here to interact with volumes and things like that. So I think I might actually leave these two as they are for now. We'll skip that one. The only difference being instead of attachments, they're children. Okay. So port to zone 2, this one is actually a volume. And we had a static mesh here, a child, just so that we could like visually see where it was. But really, all of these properties here belong up here because they're kind of a part of, they're a part of that. So we have volume, which is the type of entity is volume. We have the transform for it. The shape type is going to be a sphere. We have a radius. Extents is only used if this is a rectangle, right? But I have it in there as an example. We've got some tags, right? So if we wanted to add more tags, it might be, some other tag, right? And then this is the volume type is a trigger, right? So it's, as opposed to like a weather volume or something like that, or a physics volume. And then we have console commands that get executed when you enter it, when you leave it, only if these tags actually match up. So you'll note here that this hit sphere has a tag of player, and that is here. So since those two match, they can interact. This should also be hit shape tags because it's not just a sphere anymore. And this needs to be hit shape. Forgot about that. Shape type is going to be sphere. So let's see. So I guess we can probably leave that fine. That's fine. That's just a visual representation so we can see it. Then we've got a few static meshes here. So these, instead of having an attachment, these properties just get hoisted up. Like that. I think I'm going to normalize putting the type above even the transform, just so it's for readability purposes. I think that's reasonable. Okay, so this is a teleport. We've got that one. We have the tree here. Here is what a water plane would look like. So the water plane in this case doesn't really have anything specified, although per our new version of this, we are going to have a size. So I'm going to say the size of this is going to be 256 units. And then we have fire here, which is just an audio emitter. And we can take all of these properties. Actually, let's just get rid of this and this and move that over there. Okay, so this is sort of the human readable version, right? Which I think makes sense. This is going to be easy to edit. But we don't want to ship with this because when we think about a fairly complicated scene, especially one that's going to be in the middle of a city or something like that, you're going to have all sorts of various objects around. You might have multiple water planes. You're going to have thousands upon thousands of individual static meshes and animated meshes and all kinds of stuff, lights, etc. And so when we think about that, this file would get huge, right? Because this, it's fairly verbose. And so we really need to think about also like what a binary sort of representation of this might look like. And so we're going to wind up having sort of two versions of this file. And the way that we're going to tackle this is we're going to have this text version of the file. And this is going to get compiled, for lack of a better term, into the binary version of the file. And then the binary version of the file is what we're actually going to load as the asset. So when we actually go to parse that out, that's what we're going to load. And then when we go to ship, all we have to do is ship the binary version of it, and we don't ship this, right? And so essentially, this is going to provide us a quick way to be able to edit things and quickly go into to tweak. I think our editor, at least initially, will support this format and probably even write out to it. And then, we'll have a process that goes ahead and compiles this or bakes it or whatever it is that we want to call it. And I think that makes the most sense. And then we may eventually, like once we're way past the point where we're adding new types and things like that, we may eventually completely get rid of this format altogether. But I think the first sort of step to that is to kind of get this working and get a parser written for this. Let me just make sure that I didn't miss anything in here, because this is actually going to be the first file that I'm going to use as a test for when we actually go to parse this thing. So I think we are good. I think everything here looks pretty good. Bit Wrangler, first time chatter, welcome. Hope you're doing well. The Kohi project looks awesome. I appreciate that. Thank you. I can't wait to actually have some visual stuff done on this sometime soon, some visual updates. Because we actually have the tools to make a lot of different stuff, but we don't have like a lot of artwork made for it yet, so it's kind of hard to show off at the moment. Had no idea where you're streaming. Yeah, so I stream on Wednesday nights and Thursday nights right now. Okay. So I guess at this point we should probably start looking at our parsing. So let's do Illumina scene. And I think I'm just going to go down here to the bottom and we're just going to kind of start building out what this might look like. So let's see. I hesitate to use the term parse, right? Because we technically need to read from this and write to it because we need the ability to save too. So I guess really what we want is serialize and deserialize ultimately. So I guess we'll call it that. We'll call this, we'll do deserialize first. And since this is a static function, it's only going to be declared in here. I'm just going to call it deserialize. We're going to do file content. So that's just going to be read in as a string, right, from our asset system. And then I guess we'll just output an Illumina scene. Right, we'll just do out scene. And then we're returning a Boolean. So obviously if we fail at any point, we can just return false. Okay, also there's version business up here. I'm tempted to reset this because like we're still very much in like pre-alpha and we're technically not reusing the old format. This is technically a brand new format. So I think I'm going to reset that. And actually, now that I think about it, the file extension on this is KSN, which is Kohi scene. So that was more for our generic scene format, right? This is not that. So technically speaking, we should probably also think about a new file extension. Let's go with we were thinking of a new scene format here. Yeah, I'm going to delete that. That's old. Let's rename what do I want to call it? Illumina scene. That's a really long ISN, I guess. Illumina scene. Illumina text scene. And then binary for the binary version. Maybe you could just get rid of the N, right? ITS and IBS. No. IBS is irritable bowel syndrome. I don't think I want to call it that. Maybe we do that. 5 letters isn't too long, right? I think that's fine. That should be fine. Yeah, we'll call this text scene. I think that's acceptable. We'll have that be our new extension. Okay, so KSF Kohi scene format. Well, that's the thing though, right? It's not, so we're switching away from it being a Kohi specific format, right? Like KMT for Kohi material makes sense because that's a Kohi specific, it's an engine specific thing. But this is an application specific thing. So it's not like scenes won't exist in Kohi anymore after we're done with this. We'll have a template that comes with an example of a scene that's probably going to be almost a dead copy of this. But it's going to be completely driven by game code going forward. So like you could, and this kind of goes back to the original design decision that I made early on that I kind of moved away from for some reason, where the core of the engine doesn't actually include a scene and you don't have to use one to render stuff. Illumina scene description, ISD. It's not really a description though. I mean, it has a description in it, but I think Illumina text scene makes sense, right? And then we'll have a binary version of that. It'll make it fairly obvious what it's for. I think I'm going to stick with that for now. It'll be easy enough to change later on. So obviously, if we do not have file content or we do not have out scene, whoops, cannot deserialize without file content and out scene. And we'll just do function macro there. Turn false. And just to shut up the compiler, whoops. Just to shut up the compiler, we'll return true here. Okay, so we're obviously going to want let's see, we're probably going to want let me see. I guess I probably ought to do, I think I could just parse this, the tree directly. I don't think I need to handle this manually. I think I can just do tree from string. So case in tree from string. There we go. So this is going to be, source is going to be file content. We're just going to pass that directly. And then out tree is just going to be the address of tree. And if this fails, did I, yep, I fat fingered that one. Let's do k error. Failed to parse Illumina scene. Turn false. I probably won't need all this guard code in here for release builds. In fact, I know I won't. So I'm only going to do this on debug builds. No sense running all of that. Oh, wait. This still has to happen, though. Let's extract this out of here. And move this guy. Oops. You know what? I'm overthinking this. Let me actually just move this up here. Don't worry about that later. All right. So the first thing we want to do, obviously, is probably check the version. And I had thought actually to like reuse what I had written from our other parser for the old system, but I don't think I'm going to do that. I think I'm going to write this one completely from scratch and throw out the other one, just to make sure that we're doing a full, sort of sanity check on all of this stuff. So let's do kson. We don't want, we want object property gets that's going to be an int. Okay. So the object itself is going to be the address of tree root. The name that we're going to get out of here is going to be version. And then I64. Right, it's just going to be version. Right. And this is going to be one of the ones where if this doesn't exist, that's a problem. Right, so missing root property, property version. Probably going to wind up macroing that, but anyway. So I guess we could probably say in here, we should probably have something that determines like what the current version is, which of course for right now is just 1. Because whenever we load an older version, we're going to want to convert that to the newer version's representation of memory. And then when we write that back out, we're going to want to write out that new version. So I don't know that that's going to matter yet, but I wanted to put that in place anyways, just in case it does. So I guess I could just do a sanity check here and say if version I guess if version's not equal to 1, invalid version, invalid Lumina scene. You know what? I should probably write out the function name every single time. And then I'll also write out the actual version number. So in this case, I'll do function and then version. Let's see. Good evening, people. Hope your day is going good. It is. Thank you for asking. How about you? First time chatter, by the way, welcome. Okay. So we've got version, then we'll have to get the name. So the name, we're actually going to, we should probably, let me take a look at the properties that are in Illumina Scene, because I don't think we have some of these in here, and we are going to need them. So let's see, we have state flags and then all the entity stuff. So we actually haven't put some of the header level stuff in here yet. So the version doesn't really need to be a 64-bit int. Like we just kind of parse all integers as that. The version can really be just a U8, honestly. So we'll do version there. I'll do kname name here, and then I'll do description here as well, right? So name is a kname, which is our sort of hashed naming system that we use for quick string comparisons, and then description we're not ever going to have to compare, so that could be just stored as a standard string. And then I guess we could also put some of these other things in here. So we can do kname. We'll do skybox asset name. And then skybox asset package name. Part of me wants to wrap these in like another substruct, but I don't know if it's worth it. So I'm just going to roll with these as is for now. So let's see, this one's a vector 4. So that's going to be directional light color. And then the direction is also a vec4. That is going to be changing.
You dingus.
We're going to use a transform instead on that in the future. I do need to actually change that at some point. Nice beard. I appreciate that. Thank you. Any thoughts on forwards, backwards compatible serialization? Yeah, so at least with this format, I'm already kind of considering that by just putting a version in here. The only things that I would actually have to increment the version for ever, though, would be actual format changes. So, like if the names of some of these properties change in between releases, right? I'm not going to like increment this once while we're still kind of working on it every time I change the format. Once this version goes out, which is 0.11, then that'll sort of cement version 1 of this. And then version 2 might maybe add or remove various properties in here. And I would add that in based on the version here, right? And so if we read a version 1 file, then I would have some sort of translation that's specific to the property itself to translate from the old one to the new one, or something like a reasonable default that can be used, something like that. And then when we go to save the scene or serialize it back out, we would only ever serialize in the most current version. You're making everything from scratch or using some libraries like STL GPU? So I'm making, let's say, 95% of it from scratch. As far as the windowing stuff, that's all written from scratch. That's using Win32 or X11 or Cocoa on Mac OS. And we've written all that from the ground up. All of our renderer code is all written from scratch. The only libraries that we're actually using is in my import process, which is external to the engine, is STB image, STB TrueType, and a couple of importers for various audio formats. But other than that, yeah, there's no libraries used at all. I mean, unless you count like Vulkan, but there's not really a way to get around that. What is the theme skin? I love it. So this is actually Adwaita, but it's my version of it because the author changed it recently, and I was not a fan. Let me pull it up real quick. Let's see, where is it? Here it is. So it's adwaita.nvim, but it's my version of it. I forked it from this one, and it was a really good theme, but recently he sort of changed the color scheme, like, a lot. And so I actually forked it and kind of put it back to what it used to be, because I like that better. See, like, it actually, like, the newer one actually kind of looks like this now. And so my fork doesn't, like, change any of the README or any of that kind of stuff, but it just, I just have some changes in here for the actual colors to change them back to what they were before. So what I can do, I'll drop this direct link here, But I also have that link, which takes you to this page, and it goes over my NeoVim setup. And it's got a link to a GitHub repo that has my NeoVim.files on it. So between those two, you should have everything you need. Yeah, no problem. Let's see. So many amazing technologies from NVIDIA, such as DLSS and ray tracing. Are you interested in integrating them into your engine? Nope. Well, ray tracing maybe. Ray tracing I might actually do. DLSS no. Why X11 over Wayland? Well, so as I had mentioned at one point earlier, this project started like 4.5 years ago. Wayland was in really rough shape 4.5 years ago. And so I just went X11. I'd written X11 applications before too. I've not written a Wayland one. So X11 is what we have for now. Wayland is planned for the future. I do have it in my backlog of stuff. Just haven't gotten to it yet. But I am going to make a Wayland layer for this as well. It was in rough shape 1 year ago. Yeah, exactly. Yeah, no kidding. But yeah, that's kind of my reasons behind that. All right. So let's see. This is a F32 directional light shadow distance. I'm just going to say dist. And let's see. We have fade dist. And then split multiplier. All right, so those are all for that. And then all of these entities we can create using these arrays here. So we should be good as far as that goes. Okay, so we can start by processing these guys. So the first thing that we're going to want to do is probably, I guess we'll do the name first, right? So we'll say if, should I require the name? I guess the name should be required. I'll say if not, KSON object property value gets string is kname. And then we'll do tree root. The name we want is actually name. That's already there for us. How convenient. And then the kname that we're going to output is going to be in outseen name. Oops. And so if that fails, if it's not found, oops, I misspelled Illumina. Again. There we go. Okay, invalid missing Illumina scene name. Oops, I want that one. I don't want that one. Okay. Also, let's call this i64, version i64. Right, and we'll also do the same thing here. And here. Oops. Here. There we go. However, we can do outseen version equals u8 casted 64, right? So we'll sanity check it here. I guess we could also do a debug assertion that version i64 is less than u8 max. Okay. So we have the name, and then description is going to be the next one. So this one's going to be optional, so I'm not going to check the return value of this one. value get string. So the address of tree.root. Oops, this is going to be description. And the out value is going to be the address of out scene description. Right, so since this is optional, I don't care whether or not it exists. We'll just not do anything if it's optional. Or if it doesn't exist, rather. Okay, so I guess technically speaking, we don't have to have a skybox. Skybox could be optional. Because if we have a scene where the entire scene exists, say, underground or inside of a building or something like that, we don't really need a skybox for that, right? We'll have other stuff that gets rendered instead of a skybox. So skybox is also going to be optional. Optional, if I could spell. Yeah, okay. Skybox is optional. So realistically, it's going to be this minus that, right? So it's going to be skybox asset name and then skybox asset name. And then same thing for the package. It's going to be skybox asset package name. Right? Same for that. Technically speaking, some of these properties are going to be optional. Or actually, I guess all of these properties will be optional. This gets interesting though. If I say the directional light's optional, right now, technically that would mean that we don't have our cascading shadow maps of any kind. Which could be a valid scenario inside of like a cave. We still need to implement shadow maps from point lights too. I guess it is technically a valid scenario to not have a directional light though. So would you just have to have a way of sort of recognizing that that there is no directional light. I wonder what we could go by for that. Because I'm also thinking these shadow properties, we could have these things as reasonable defaults. Technically, all of these could have reasonable defaults, except if you don't define, say, color. If color isn't defined, then we'll assume that none of these exist. Or maybe we'll just ignore them. But if color is defined and any of these don't exist, then we'll want to create them. I think that's a fair rule. So let's say...
You dingus.
Thanks for the follow. I appreciate that. Directional lights are optional. But we're still going to check. So we're going to say if property value gets, it's going to be a vector 4. So we have the address of tree root. This is going to be directional light color. And we're going to have the address of outseen directional light color. So if that exists, check others. Other light shadow properties, or use defaults if they do not exist. And then else, if no directional lights, ignore other properties. Which we technically don't need the else here, right? That'll get compiled out because it's kind of a no-op. But I'm putting it there for clarity as to what the heck is going on, right? So the next thing is we'll have another vector for that we'll have to get. So I'm just going to do this. Except this one's going to be a negative check. So if we don't have directional lights direction, then we're going to say outseen directional light direction is equal to and I'm actually just going to use this as my default. Obviously, I'll have to convert this over to use, F's and commas, but right. Okay. So the next one's going to be an F32. So if not case and object property value get float tree root. We're going to want directional lights shadow distance is going to be the one we want. Oh, you know what? I called it distance here. I should probably be. Let's do that. There we go. Okay. So if we don't have that, then we'll say outseen shadow distance is defaulted to 100. And I'll just essentially do the same for the other two. So instead of shadow distance, that's going to be shadow fade distance. And then shadow fade distance here is going to be just 5. And then the split multiplier is going to be 0.75. So this will be shadow split mult. Directional split mult. There we go. Okay. And the same thing there. All right. So that is pretty much it for the global properties. And now we basically just have to work our way through the entities array. So again, we've got the ability to nest these under children. So we're going to need some recursion here is going to be the only way that we're really going to solve this one. Reasonably anyways. There's other ways, I suppose, but I think this is probably the most straightforward. So I'm going to say static B8 deserialize entity. So this is also going to require, how do I want to do this? So I'm going to need the case and object and that's essentially going to be like the parent object, right? And the scene. I think that's all I'm going to need, actually. Out scene. So this one I'm not going to bother doing any sort of checking on in terms of making sure that these things exist, because this is only going to be ever called by this guy. So I'm not going to worry about that. Let's just do that first. And what we'll say here is, I suppose we'll need to get the, we'll need to get like an array of properties first, right? So every entity could potentially have a name, a transform, a type. If type isn't provided, it's assumed to have a type of none. And that should be it for right now. So I guess I could do, I guess I'll do type first. So the type we're going to have to get as a string, and then convert that to, we're going to have to convert that to an entity type. So we're actually going to need something for that. I'm going to put it in here for now. I'm probably going to wind up moving this, but Illumina entity type. Illumina entity type from string. So here we'll have to do if what are all the types? Let me just grab all of those. All right, so I'll do if strings equal I, string and then none, or we'll say string length. String is less than 1. Or actually, the first thing we'll do is we'll say if not string. Right? Because those will all sort of cover the same kind of case. In all of those cases, we can return that. So let me actually just do, see if I can automate this a little bit. So let's do that. We'll do else. right? So this is going to be static mesh. And actually, the only thing that we want to check is that. And the rest of them are going to be this way. So it's going to be I think I can just do that. Maybe I should have this as the else case, right? Or maybe I just do maybe I'll just do that for now. Doesn't really matter. All right. So height map, terrain, water plane, audio emitter, oops, emitter, volume, hit shape, and obviously we'll have to add others to this. Point light. All right. We might as well make the opposite of this while we're at it. So we'll do Illumina entity type to string. And this one's actually easy because we can just switch on type, populate that guy, and then just do return height map terrain, return water plane, audio emitter, spelled it wrong again, return volume, return hit shape. Oops. Return point light. Oh. So for these two cases, I'm going to return none. Actually, I'm gonna do that, but I'm gonna throw an error too. So function name tried to convert invalid or count to string you dingus. Right? Okay. And I'm not going to default this because when I add a new entity type, this will bleat about it. And that'll be a hint of, oh, I have to go through to all the different places and add and fix that. All right, so all of that to get the type. So what we really need here is a constant character array, and we're going to call this type string, and that's going to be 0. And we're going to say if not case and property value get string, right? And we actually want to get this as a string. So it's going to be object, and then the name here is going to be just type, and then out value is going to be the address of type string, right? So if that doesn't exist, and I'm going to do, actually, if that doesn't exist, I guess let's cache this here first. Illumina entity type. Entity type. You know what? I could actually just default it here. I could just do Illumina entity type none. Right? And then I don't even have to worry about this. If I don't find it, it just doesn't change it. Okay. So, if we do find this though, we do have to do some processing on that. We'll do entity type equals Illumina entity type from string. And we'll do type string. Right, so we'll have that. And then we'll also need to string free type string, right? Because that will have been a dynamically allocated string, as mentioned here. Right. Okay, so anytime we deal with like something that's an enumeration in this, that's kind of how we have to do it. I would love to find a way to where maybe I could provide some sort of metadata to not have to go through all these hoops to do that, but for now we're limited. Okay. So name is going to be optional. So we could do kname entity name, and we'll do invalid kname. And then we can do KSON object property value get kname. String is kname. That's what I wanted. So we're going to get that from the object that's passed in, the KSON object that's passed in. The name is just going to be name. And then we have the address of entity name. And it's optional, so I'm not going to check to see if it was successful. I don't care. Okay, so transform. I'm pretty sure didn't we have... I could have swore that I had something in here. I could have swore that I had something in here to get a transform. I must have done that in the old scene. Nope. Scene node transform gets. Maybe the hierarchy graph does it? Oh, that's going to be... Let me try searching from the bottom. I could have swore that I wrote a function for this. Apparently not. Okay. I guess let me try one more thing. Transform from string. There it is right there. But I have to extract it as a string first. Okay. Okay.
You dingus.
Thank you for the follow. Appreciate that. We're going to do transform string. And then if we have object property value get string, object name here is going to be transform. And then we're going to output that to transform string. And if that's successful, then we'll do a k transform from string. The string is going to be transform string, and out transform is going to be I guess just that. Now, true and success, otherwise false. What can cause this to fail? I don't remember. Not providing a pointer for one thing, or a string. Or an invalid number of elements. Okay, so theoretically, there's a few ways we could actually crap out of that. Okay, so I do need to check that. If that fails, what should we do? We should probably have, I don't want to just say invalid transform, right? I should probably maybe warn about it. Invalid transform provided, defaulting to identity transform. I'm technically going to count this as a success, but just warn about it. Okay, transform. Can we just do create? Yes, that's exactly what I'm looking for. Okay. So we'll do T equals transform create. Right? And then if we don't find this, we're also going to do this. Although, we might actually want to say invalid transform. Because technically speaking, we can have entities without transforms. Right? Or do we want to support that? I kind of feel like now that's such an exception case thing. First time chatter, welcome. How's it going? Welcome to the stream. All right. Let's actually dispense with the idea of transformless entities. I can't think of a compelling enough case to make it worth it. Because the thing is, if I have cases where I don't have a transform, then I have to switch on that logic and look further up the tree for the next transform. So it's just like another path of code we potentially have to go through, when I could just say, let's just always have one. Okay, so transform is optional. Use a default one if one does not exist, or was invalid. Okay. All right, I think that makes sense. Okay. So we have name, type, transform. The next thing that we have to do is all the way at the bottom is recurse children, right? So the way that that's going to work is we will say if casein object property value get array, right? From the base object, we want to get something called children, right? And this is going to be casein array, children array, right? So that's the actual, this bit, right? So we get that to that. If we have children, then we need to recurse through them. If there are any. Right, so the first thing that we need in order to do that is we need to actually find out how large the array is, which this will tell us. So I think it's U32 array length. Right, so casein object casein array. What is it, length? Was it length or count? Was it neither one? And I'm just, am I a dingus? That's the question. Element count get, that's what it was. I suppose that's not the best name function. Casein array element count get. There we go. All right, so the array is going to be children array. And then the out count is going to be array length, right? If for some reason that fails, then we're not going to do anything. We're basically just going to pretend it doesn't exist and not recurse the children. I guess let's put the negative case here. So we'll say k warn could not retrieve length of children array. Skipping. Okay, so what we'll do here is we'll just set up a simple loop. U32 I equals 0, I is less than array length plus plus I. And we'll do a retrieval of each child object. So we'll say casein object. And we'll say child. And then we'll do if casein array element get object, right? So the array is going to be address of children array. The index is going to be I. The object is going to be the address of child, right? So if that exists and is successfully retrieved, then we do deserialize entity. And this time we pass the address of child as the object, and then just pass out scene, right? And then we can also say if not deserialize entity. We can say k error failed to deserialize child entity. Return false. right? Now, obviously, we can make the error handling a little bit more robust than that in the future. We're just kind of trying to... Oh, did I misspell something? Wait. On line 1213. I must have... Did I fix it? Up 5 now. Oh. Geez. Thank you. That would have been a nasty surprise. Appreciate that. First time chatter, welcome, by the way. Okay. So that's the recursion. Now we actually have to handle the individual types. So this, we could just switch on the actual type. So entity type. And we can actually just cheat and do that. So I'm just leaving that there, right? Intentionally blank. These two technically shouldn't happen. Invalid entity type found. No type specific properties will be loaded. Right? We'll just throw an error about those two, right? And then we'll essentially just have to go through and fill all of these out. Let's see. Okay, so essentially what we're going to do, I suppose we could go type by type here, right? So static mesh. Static mesh, I think, only actually has two properties, which is these two things. So that's actually fairly easy. But one thing we don't have yet, one thing we haven't actually done, we've extracted all this data, but we haven't actually put it into any kind of entity, right? Namely because we don't know what array we're going into until we get to this point. So how do I want to handle this? I really don't want to go through it twice. I suppose I could do the base properties down here after I fill out the specific properties. I guess I'll do that. So I'll do static mesh entity. We should probably use already use the actual functions that I've already created to do all this. Illumina scene, add static mesh. Let's see if we can make this work. So out scene, k name is just going to be name, right? We already have, it's going to be entity name. Asset name we need to get, package name we need to get, transform, that's just T. So Do we have any more? Okay, I can do this. And I'm going to have to wrap this because I know it's going to bleat about scope if I don't. So this is going to be asset name, asset name, asset name. And then the same for package name. So package name, if that's not, if package name doesn't exist, that's fine. If asset name doesn't exist, that's an error. Because if package name doesn't exist, we just assume the game package. Failed to serialize static mesh entity. Missing asset name. And this is going to have to return false. Okay. So if this fails, then we also need to that would have already logged an error, so we'll just return false. Yep, cool. I think that makes sense. The only thing that we don't have the capability of doing, because we haven't actually passed in a transform, a parent transform of any kind, so we're actually going to need to do that. We need to add that in here.
You dingus.
So this is going to be parent transform will be that when we recurse. Okay. That will ensure that the transform is handled correctly. Right. I don't have the hierarchy graph set up yet. We haven't done that yet. Okay. That's a major to do. Did I spell that right? Hierarchy graph. Okay. So the hierarchy graph, I guess we already have one like coded. It's not like I have to make that from scratch. I just have to add it into here. I just have to actually add it. First time chat, Xcoding. Hello, welcome. Hope you're doing all right. That all being said, I do actually have to get up for work in the morning, and I've actually run over quite a bit in time. So I think I'm probably going to call the stream here for tonight. We've done a lot of stuff, but yeah, thank you all of you who joined in and rated. I really appreciate all the follows. Just arrived at work. What are you working on? We're working on our we're working on the game specific scene. So we're building a game specific scene to go with our game specific renderer. Because the game code knows what the data is, how it needs to be represented, the order it needs to be rendered, things like that. So thanks for the dingus. Yeah. For those of you who are wondering about all the dingus references, by the way, we kind of coined a term on this channel a while ago called dingus oriented programming. And that's where I do stupid stuff. on stream, make stupid mistakes on stream, like copy pasta errors and stuff like that, or misspelling things that sometimes chat will call me out on or, help me fix. But I call that dingus-oriented programming. So that's what that's all a reference to. But yeah, this is where I'm going to leave it for tonight because, like I said, I do have to get up in the morning and work early. So I am going to go ahead and commit this. I'll push it up to the repo tonight because I don't want to have another scenario where I have another hard drive die on me and I lose it. So you looked it up online. Yeah, I've actually been thinking about creating dingusorientedprogramming.com, be super funny. Let me find somebody to raid. Hopefully we can kind of find something that's somewhat related. Actually, looks like Randy is streaming, so let's actually raid him. All right. So yeah, anyways, thank you guys for being here. I really appreciate all the interactivity and all the follows and all that good stuff. And again, big thanks to John for the raid. And yeah, I will be back here tomorrow night, probably just before 9, and we'll pick this up where we left off. So thank you again. If you haven't already, I would really appreciate a follow, either on the YouTube side or on the Twitch side, whichever you choose, or both if you so choose. And yeah, I'll see you guys tomorrow.